Seriously?
Hey, folks. We have to do this entire intro again. No, we'll keep it short. So, hey, we're starting the Chicago Kotlin user group. Welcome. Going right to the slides. All right, so we have a few ground rules. It's been the same for like 8 to 10 years. We believe in being inclusive. Chicago Kotlin user group is an inclusive and accessible. True, I do that all the time. We're an inclusive and accessible group. You'll see that's why we mask up. It's a bit outdated, but we were doing that at one point. So do everything in your power to be curious, to ask questions, and avoid assumptions. And do everything you can to continue to grow trust, empathy, and friendship. We do not tolerate harassment of any kind. We are looking for speakers for the 2025 year. We actually do have some on the queue. It's just not on the meetup yet. We're trying to work some of that out. I know we have one online one. There's like another in August. We're sort of trying to sort. Someone wanted to visit Chicago, and it's like a whole thing. So yeah, we are still looking for other speakers. We have never turned down a speaker. And all the talks have been really great. We encourage experience, and brand new speakers are especially welcome. So even if you're not located in Chicago, if you want to give a talk, there should be something in the description. And if you join the user group, I periodically send out invites on this year-round CFP. Okay. All right, couple ways to keep connected with the Chicago Kotlin user group. We do have a Mastodon. I lost the password to it. I have to ask John to help me out with that one so I can properly get back on that one. We do have a Chicago Slack, and other than that, social media has been pretty exhausting. So I think what we've all agreed, like me, Mary, and John, we're just using our personal stuff until something takes hold, and then maybe because like after so many accounts, and now you're managing your own, plus that it's too much. So that we do have these. Okay. We normally do something with Java user group. Not new news, but if you're interested in connecting with them, they do have a Slack, and they do have a LinkedIn, which is very popular. We also have a YouTube channel. You can peruse like all our YouTube talks. They're all really great. And you can see this particular talk as recording on this channel as well. Okay, thank you for the IIT Product Management Club for hosting us. Sorry our host couldn't be here, but that's okay. We'll keep it sweet and short, and we're just gonna follow along. And for those that are watching live, I'm gonna keep an eye on the chat, and you can like ask questions and interrupt, and I can try to be a voice to ask Kartik in case, I mean, he already has his chat too. So I would say if you see the questions, just like read out loud what the question is, and before you answer it, just for logistical sake, really. Yeah, I hope folks are ready. And I think another thing that is like good to ask is, even for the folks that are watching, like, are you going to do this live? Or like, if anyone's going to do this live and they have a particular computer, like you're welcome to follow along, or you're welcome to enjoy. There's no pressure. But yeah, if you have questions here, you can definitely put it in at any point. You can interrupt. We're a very participatory group. So, all right, I'm gonna give the floor to Kartik. Take it away. I guess I'll just like move the, I forgot to invite.
How do I stop sharing?
You're in the room?
I am not.
Oh, okay, hold on.
YouTube and stuff.
I just gotta invite you the link.
Okay.
Yes. All right. Hey, folks, it's really great to see you online. Oh my gosh, everything is squished, but we will, please. I don't know all these screens. Invite, copy. I'm gonna go on Slack.
Yep.
And I need to make sure this computer is like plugged in. Okay. I'm about to choke this computer. I say, even though I'm like, it's my fault, that it's this way. Okay, you should be in, and once I add you to the group, we'll be ready to go.
Okay.
All right. All right, folks. If you're just joining, welcome to the stream. What I'm going to do is, while we're waiting for Kartik to get online, there actually is a follow along if you do want to be a part of that. I left it as a comment in the meetup. That's kind of like a.
Yeah, I can post it as a comment on the stream.
Oh, yeah, that would be great. Thank you. Yeah, post it right in the YouTube. That'd be so much easier. Thank you so much, Kartik. So, yeah, you should see in the chat. Whoa.
All right, good.
Okay, we good. All right, here we go. And then if you want, you can turn the camera on. I'm going to take myself off, and you might want to unmute yours. I'll mute mine and turn the volume down. You
Sweet.
good?
All right, let's see.
Is your job why you have medical tape?
Oh no, I just have it in my bag.
Okay.
All right. I think
You're good.
let me stop presenting here.
Oh, yeah. And you can just share your screen. I think today's vibes in the room will be you drive and we mob.
Okay, want to make sure it's showing up on the stream. Still don't see it on my phone.
All right, and once you share, you'll be good.
I am sharing.
Oh, I know what's wrong. Here we go. You good now? There's a little bit of lag.
Okay, got it. Perfect. All right, welcome everyone. I'm gonna keep an eye here on chat. If you have questions, feel free to post there.
I'll keep an eye too. I'll raise my hand for
Sweet. Thank you, Amanda. All right, so how many of you have experience working with Kotlin Multiplatform? Just throw it out there.
Actually, no.
Oh, sweet. We got two here. So yeah, I guess if you are familiar with it, it's just another framework which gives you the capability of building multi-platform apps, but also lets you share your code, so you can keep your business logics and things like you're repeating over and over again on each platform in one place. So that also helps you to be consistent across all platforms. I think one of the primary use case here is Android and iOS. So we see a lot of mobile apps out there doing the same thing, but they're being developed natively on different platforms. So KMP kind of gives us an opportunity to bring all those business logic, keep it in one place, be consistent across platforms, and you can easily manage all your features. So just want to give you an overview of what we're going to do today here. We're going to do a very basic application which will support Android, iOS, desktop, and web. I was kind of debating between what app we should do. I was debating between doing like a to-do app or a weather app. I thought I went with weather app because it will give us an opportunity to explore making network calls, but also doing some storage level things. But let's see how far we get at a given time. So some of the things that I would like, if you are doing like a hands-on, if you're trying it on your own, there are a few setup stuff that you need to do. We need an Android Studio installed. You need Multiplatform IDE plugin in there, enabled and installed. We also need Compose Multiplatform plugin. That's more of a choice what JetBrains was trying to do is they came up with an idea called Fleet. If you've heard of it, they were trying to make it more like Compose multi-platform oriented, but recently they kind of gave up on it. So I don't know if that plugin is up to date and it will work on Android Studio, but keep an eye out for that. Maybe it will in the future. We want to install JVM, I think greater than 17 with the latest version of Kotlin multi-platform. There's a dependency on 17 and above on that, so I just mentioned here 21, but you should be fine with 17 as well. Some other requirements if you're trying to do iOS app, these are like hard requirements. Unfortunately, Apple doesn't give us the capability of developing iOS app if you don't own a Mac. So you need a Mac machine, you need developer and build tools in there. You need an Apple account. So with Apple, there are two different things. There's an Apple account and there's an Apple developer account. If you're just developing and you're not putting anything out there for public on public stores, you just need an Apple account, which is free. But if you want to eventually push it to the store, do like beta testing, all sort of things, you need a developer account, which is paid. I believe it's like $100 a year or something. Xcode command line tools. It helps you build your packages, iOS packages. We need Ruby to build iOS app. It help you manage like CocoaPods, all different sort of dependencies and things like that. Same thing, we need JDK installed and CocoaPods. So, but this is only if you're doing iOS development. If you don't want to make an iOS app, you don't need any of this. All right, so moving on. So the very first thing, setting up your project. I'm gonna open up this link here. This is like a multi-platform wizard from JetBrains where you can easily set up like a starter project. So what I did was just put in project name, your project ID, select the platforms you want to support. I'm gonna do all, I'm not gonna do server, which is gonna do like front-end platforms. So Android, iOS, desktop, and web. And it will basically download your zip file, which is like a starter project, and you can open that up in your Android Studio. So, okay, you guys can see my project. I've already opened it up over here. So once you do it, it's gonna take a couple of minutes to do like initial build, some indexing, all that good stuff Gradle brings with the phone. So it'll take a few minutes to import, but once you're done with that, I just want to briefly talk about how it is set up. So you have an idea on how the project builds, how do you target different platforms, what kind of source sets are in there, and things like that. Just a point to note here, if you run into Java incompatible issues, make sure your IDE is using the correct Java version. As I mentioned, the newer Kotlin versions require, I believe, Java 17 and above. So if your machine have Java 11 or something and your IDE is using that, you'll see some errors. But you can easily fix that in IDE settings. And lastly, if you're not on a Mac machine and you do not want to do iOS, just comment out these lines of code in your compose app build.gradle file. So you can find it right over here. Yeah, you want to comment these out if you don't want to build for iOS. All right, moving on. So once you have imported, let's just give it a dry run. Let's just run it and see if it's even going to work. This is a good way to make sure everything is set up on your machine before you go into actual development. So I'm going to just do like a desktop run. I'll do each platform actually, so you'll get to see. This is just the starter project. Just kicked off a desktop application. You just click it, it shows the Kotlin multi-platform icon. So that's desktop. I'm gonna let's do like a browser run. Sweet. So that's your browser app, web app. That's doing the same thing. Then let's try iOS as well. iOS builds are going to be the most time consuming when you're working with KMP. It's just the whole Kotlin native compiler and everything that comes with it takes some time.
I have a question.
Yeah.
I don't know, like, has anyone tried, well, I'm sure it's possible, but like on the same computer, it's not possible to like, probably, I mean, not an individual one, but maybe just like run both parallel.
Do you mean?
The Gradle builds for both iOS or can you only just have one at a time?
I'm not sure about that. Do you mean like building for two different platforms at the same time?
Yeah.
I'm not sure. Maybe it will. We can try it out. Okay. So, yeah, let's try that out. Why not? So, but just want to show you briefly before that. Yeah.
For the microphone, because mine's not on, but yours
Okay.
is. Yeah.
Yeah. So Amanda had a question if we can we can run two builds on different process for the same project, but for different platforms.
Yeah.
So I don't know. We can try that out for sure. Before we switch to that, this is the iOS app running on an iOS simulator. But now I'm gonna switch here. Let's see. So I'm gonna put maybe the browser run in here, which is
Oh,
yeah, I have a feeling it will run into like
One of those rail tested states running.
yeah, it's probably gonna wait for.
yeah. No, that's a good point. Yeah.
So there's browser and for desktop, let me see what the Gradle task is.
I mean, yes, you could with the device farm easily, but you know, like
It's just a browser, like it's actually like building, not
Right.
binary, but like.
I guess it's just one.
Yeah, 'cause, like, let's say you're a KMP developer full time and you have a really sick setup and you have a lot of work. Why not? Like, maybe you need to test cross-platform.
Sure.
And your CPU will start crying.
All right, so I'm,
Yeah, I know that was why I stopped asking halfway through. I'm like, well, you know, not like what we run.
so desktop was pretty, well, it did work.
Oh, two at the same time.
But desktop was really quick to compile. I guess it using cache or something.
Yes, you can.
But I guess you can. Yeah.
No, ask the question.
Yeah, go for it.
I was gonna ask, web has this idea of like, continuous updates, like normal web world. I was gonna say, if this were here, now realize we're compiling the binary, so they won't be like library load.
Yeah, I don't think it has live reload. I'm not sure because using the whole WebAssembly combined stuff, so I don't think there's live reload.
Don't forget to explain it to the
Yeah,
rest of the
sorry.
crowd, and
So-
also, don't assume they know what binaries are.
Okay.
Yeah.
So the question was, usually in the web world, if you're writing like a JavaScript web app or something, there's like a live reload. So if you change your JavaScript file, go to the browser, it will update right away. But with KMP, I don't think that's possible because for the web side of things, KMP is using WebAssembly. So it's going to compile everything into the binary package, and then you can open it up on your browser. So unfortunately, I don't think it supports live reload.
What are you building? It's taking a minute and 30 seconds.
Oh, no, that's just the web app running.
Oh, okay. So
Yeah.
got you.
So if I kill it here, that kills the web app, and this is the desktop app. I'm going to kill it again. Cool. All right, so we were able to run the app on 3 different platforms. I didn't run Android. I can. Let's see. Right, it's building the Android app. And I have an emulator running here. Should install it on that.
Not that bad, not that bad. It's gonna be worse than what actually happened today, but it was my first one. I haven't tried any of the machinery yet.
Yeah, we're talking about build times over here. Those are scary.
Oh, yeah. Okay, cool. So people can't hear us. They just want to confirm that. I don't know.
Okay.
Oh, would you mind explaining what WebAssembly is?
So
Yeah.
I'm not a expert on that, but
Don't forget to repeat the question. Sorry.
how about we look it up? I'm not a web guy, so.
Sorry. I thought I knew for a second. I'm like, wait, no, I don't.
It's a compiled format. Like a bunch of different languages can compile to WebAssembly, and all the different browsers know how to execute WebAssembly.
Gotcha.
It can be both for UI, but it can also be for like
Server
essentially
stuff.
like headless computation stuff.
Okay.
So, like, this is such a stupid question. All right, let's say you do web development. Like, if someone wanted to look at WebAssembly, is that just an entirely different framework altogether? Or could you theoretically access it from the browser?
So I was messing around with this a little bit. At work, we wanted to do some compose multi-platform. We have a view in our app that is very customizable. We wanted to have the admin portal on the website show a live preview. And I messed around trying to get it to work. It's a pain in the butt. And JetBrains tries to do a lot of clever things for you. There is a way to hook up like the IntelliJ debugger into the live running web page.
Interesting.
You're really out in like the Wild West as far as like, trying to do stuff.
This interests me. We should talk about that later because I've been playing with coroutine debugging on IntelliJ and things that you're not really supposed to do. So I need to see that. And
Interesting.
I don't know, like.
Yeah, so for all the folks online, someone was just trying to explain how they have used WebAssembly, and there have been some
I'm trying to add comments about it.
opportunities around debugging a live running web app.
Somebody said that the screen is a little blurry. I'm trying to look into that, but.
Okay. Do you want me to dial down the resolution, maybe?
Can you actually increase the size of the text?
I can.
Because, I mean, even me.
So,
Is that, let's see, you know what?
is that good?
Actually, yes.
Okay.
Yeah, that's actually, it looks great.
Sweet. Hopefully it's helpful for folks online. All right. Next, let's jump into understanding the whole multi-platform setup. So there's a notion of targets and sources. So as the name suggests, target is what platforms you want to target. Do you want to build your app for Android, desktop, iOS, WASM, which is JS for web apps. You can do like Linux desktop, and you can do just iOS simulators and all sorts of things. So I'm gonna jump into the code here and show you how do you declare your targets. So let's see if I can increase the text size here. Yeah. Oops.
You can also command comma.
Oh, there you go. All right. So this is our the shared modules build Gradle file. If you have done any sort of Gradle project, you're familiar with build file, but it basically lets you define the configuration for your project, what dependencies do you want to use, all the build time configuration. So we have the Kotlin multi-platform plugin applied to our module. And once you have that, you have access to this nice Kotlin block, which will let you define all the targets you want to support in your app. So as you can see, we got an Android target, we got all different iOS targets. We have JVM, which is for the desktop app, and we have the WebAssembly.js target here. But maybe let's see what all does it support. So we got Android target. We got like Android native. iOS, which we already have in there, iOS simulators, just JS itself, which is not using WebAssembly, JVM. Then, like I mentioned, you can also target just for like Linux machines and for macOS as well. And I believe you can do Wear OS. Oh, there's tvOS as well. Nice. I'm sorry?
There's Linux.
Yeah, there is Linux. There's tvOS. And I thought it has Wear OS as well. Maybe not, or it's called something else.
Android Wear.
Yeah. No, I'm pretty sure it does have Wear OS.
Where else is it? Right?
I'm sorry? Yeah, at the end of the day, it's just Android. Cool. So yeah, this is how you define your targets. One thing that I want to highlight over here is like this part of the configuration for iOS. So folks who are familiar with making iOS apps and using Swift, the way Kotlin multi-platform is using this shared module, it's going to basically build out a binary, and then if you would have noticed, in your project hierarchy, you'll see like an iOS app folder, which is your actual iOS app. You can import it to Xcode and do things there in Swift if you'd like. But at the end of the build, what's going to happen is it's going to build out a binary called compose app, or whatever name you mentioned here in base name. And you'll be able to use everything that you expose through this shared module on iOS side of things in Swift. So let's say I have a class in here in my shared module, XYZ. I can go into Swift, you do it like an import compose app and use that XYZ class if you like to. Yeah.
So this implies like the name of your app is like this base name, and then each target will be like a suffix next to it. So if this is like the weather app, this would be called weather app as the base.
So for each platform, I think you'll define it differently. So like an Android, it will be in the Android manifest. You'll define your app name. On iOS, it's in, I think it's called a plist file, where you define all the key value properties for your app name.
Is it a good rule of thumb not to make the base name the name of your app?
I have seen different things. Obviously, the starter kit has it compose app. I have seen shared being used a lot. Then we have like a multi-module build where we have multiple modules that are being shared, so we name it by the module name. So for the folks online, the question was, is if there is like a rule of thumb defining the base name of your shared module that gets accessed natively on each platform. I don't think there is any. Most of the project use like a shared, they just name it shared. So it's more like contextual based. Sweet. So the next thing about after targets like source set. So source set is where you're going to define your dependencies. Now, there are a lot of libraries out there that are already multi-platform, so you can use them right away in your shared module. But once in a while, I would say we're still in early stages where you'll find a need where there's no library out there which is multi-platform, and you want to still do something with that library. So that's the beauty of Kotlin multi-platform. You can still use it. You just need to set it up a little bit. And I'm going to show you how. So let's look at the source set first. So for each platform, you have a defined source set in your project. So in your shared module, which is our Compose app, if you go down the line, you'll see Android main. Let's ignore common main, I'll come back to that. You'll see desktop main, you'll see iOS main, you'll have Wasm JS main. So you'll see it for each target platform you're supporting. So anything that is supported only on that platform, all the code related to that will go in that source set. So if, for example, if I'm doing something specific to Android that is not available on other platforms, I'm going to put it in Android main source set. And same goes for like desktop, iOS, and Wasm.js. But like I mentioned before, there are libraries out there which support all these platforms that you are supporting. You can just add that dependency for common main and just use it once in common main. And let me show you an example here. So here you define your source sets. So for each target, each platform you're targeting, you can define all those dependencies. For Android main, like we have Cater client Android, Compose preview. For common main, these are all the libraries that support multi-platform and all the platforms that I am targeting in my app. So there can be a situation where a library is multi-platform, but it's not targeting all the platforms your app is targeting. So you cannot use that in common main. So whenever you're looking up a library, make sure before putting it in common main, it's targeting all the platforms that you are supporting. If it's not, you can still use it, and we'll talk about that in a little bit on how to do that. Yeah.
So you just have to like repeat everything.
For each platform?
Yeah.
No. So if it's a multi-platform library supporting all the platforms, you just declare it in your common main. Oops, what is that? Okay. You just declare it in common main, and you can use it on each platform.
So those Android ones are like starting off the platform.
Don't forget to repeat the question.
Yeah. Sorry, can you repeat it for me?
Sure. Are those two Android X?
Yeah.
Their implementations, they target multi-platform?
Correct. So there's Kotlin. So the question is, I have these dependencies here, libs.androidx lifecycle view model and androidx lifecycle runtime compose. They're coming from androidx package, but what are they doing in common main? That's the question. So, okay. So the whole compose multi-platform is the shared library for all platforms that you can do your shared UI. And it's basically following the footsteps of Jetpack Compose. So they haven't renamed the package. It's still Android X, but it is multi-platform. So the lifecycle, Android X lifecycle module and group supports all the platforms that I'm targeting here. All right. We got no iOS folks here. Cool. So yeah, once you have defined all the source head, like I mentioned, anything that is specific to that platform, you'll define it in the dependencies for that platform, and you only needed to do it once for all the common dependencies. I should stop doing that. All right, I already went over platform dependencies. Cool. So yeah, like I mentioned in the beginning, I was kind of debating between if we should do a weather app or to-do app. But I went with a weather app, which will, let's see how far we get with it. But the basic goal is to fetch the weather forecast for a provided latitude, longitude, and the current weather for the same. So very basic, but with this app, we'll be able to explore how to make network calls, how to do serialization and deserialization of data models. We can also do some data persistence if you'd like, so maybe like a history or something. So if you have put in latitude, longitude, you come back to your app and you wanna see the history of whatever you queried before. I was trying to find some like free weather API, and I was only able to find this openmedia.com, which is free for non-commercial use. They certainly have some limitations on how many calls you can make in a day or something. We'll use coroutines to, do the whole scope management and background processes and things like that. And then we'll also go into like dependency injection using Coin. So all of these things that I mentioned here, or all the libraries that I've mentioned here, are multi-platform, and they support all the platforms I'm targeting. So we should be able to easily use them in our common module, and yeah, build up our features for our weather app. All right, so setting up dependencies. For the folks who are doing it at more hands-on, you want to go to your the libs version file, declare these versions for Coin, Ktor, Kotlin serialization, and coroutines. And then you want to declare the dependencies and the library block. So let's see what all we got here. We got coroutines core, which will give probably everything that we need. There are some specific coroutine packages as well. I think there's one specific for Android that lets you I think it has more like extension functions you can use, and maybe other features. Coin is a dependency injection library. How many of you are familiar with Coin? All right, everyone, sweet. But in the old Android days, we had Dagger. People are using Hilt now. Coin has become like a go-to for multi-platform. And it's pretty neat. I've been using it for a while. So there's Coin Core, obviously supports the common module. There's Coin Android. This is specific to Android, and it gives you functionality of, I think the major feature of it is you can do like main dispatcher. You can inject Android context easily in your DI graph. I think those are the only two I have used. I'm pretty sure it has more than that. Coin Compose View Model. This is again a common module. It will, if you're familiar with MVVM, in your DI graph, you inject a view model. It gives us that functionality, but in the multi-platform world. So you'll declare those view models in your common shared module. Then Ktor clients. So Ktor client core is the common module through which we're going to do all the networking side of things. But obviously, when you're running on a platform, you need platform-specific client engine to actually make those network requests. So for each platform, we have a client here. We have one for Android. Darwin is for iOS. Java is what we're going to use for desktop apps. And then there's one for JS.
I got a question.
Yeah.
Why do we need a different client for each platform?
So the question is, why do we need different client for each, or for each platform, why do we need a Ktor client? So when we are, I do not know the exact answer, but I'm trying to think it through. Let's see. In the multi-platform world, you can choose what targets you're building for. So
And the target is like Android. Like
Android, yeah, platform.
Make an Android app.
Yeah. So I think at runtime, or maybe not runtime, but when the Ktor networking layer compiles, it doesn't know which platform it's going to run on. And it basically asks us, hey, give us a way to use an engine which has the same interface on each platform.
Okay. You use the word interface, is the interface in the core clients?
Yes.
Okay.
Yes. So you'll see it once we start doing it, you'll see like, only thing you need is just provide Ktor what engine you're going to use, and then you just, in the common module, use Ktor as is. So yeah, that's why, or hopefully that's why we need different clients for each platform. And lastly, we had Kotlin serialization. It's again a common or multi-platform library that we can use in common module for serialization and deserialization. So again, if you are doing it more hands-on, please make sure to add all of this in your libs version toml file. And then eventually in our build Gradle file, we want to add those dependencies. So we're going to add the Kotlin serialization plugin. So this is a trick. If you're familiar with Gradle, you define it in the root build Gradle, and then you just apply it in your submodules, so you don't have to do like duplicate versioning and all of that. Then all the common libraries that I spoke about earlier will go in common main dependencies, and anything that was specific to platform, they will go in the specific platform dependencies. So Ktor client for Android goes in here, Coin for Android will go in Android main. I don't know why I have Kotlin serialization here, but it's not needed, I think. But you definitely need Ktor client Java for desktop main, then Darwin for iOS, and then JS for your web app. All right. Next big thing is setting up your DI. So as I mentioned, we're going to use Coin to set up the whole DI graph so you can inject your repositories, all the components in the graph, and share it as and when needed. So before we do that, I want to go over expected and actual declaration. This is like, I want to say the heart of KMP, which gives us the flexibility of using platform-specific stuff when there is no multi-platform library available for what we're trying to do. So I'm going to switch over to the code here and go to my DI file. So, all right. So I created a file in my common module, and I just prefixed it with the keyword expect. So what this does is it's going to tell the compiler that we're just declaring it like a abstract function, but it needs to be implemented for each platform we are targeting. So in common module, I'll just say expect function platform module, and this module is coming from coin, where you define all your components of the app to be injected to the DI graph. So once you declare this, you'll see this icon over here, and maybe let me switch here. Once you create it, it's going to highlight, the ID is going to highlight saying, okay, you have declared an expected function, but it's missing all the actuals. So you need to go into each platform, define all the actuals for them, for this function. So you'll see this nice message for what all platform it's missing, and you can easily click on add missing actual declarations, and ID will create like stub functions for each platform. And once you click on that, it's going to ask you, hey, what all platforms do you want to create it for? And obviously, you want to put all the platforms that your app is supporting. So you'll choose desktop main, Android main, iOS main, Wasm.js main. So interesting thing over here is it also lets you dive a bit deeper and declare things differently for a different set of platforms. So even you can either declare an actual declaration for whole iOS, or you can choose things differently for like iOS ARM64, simulator, and so on. So if you're targeting like Linux or Mac OS, you can choose different targets for like, yeah.
I think like both the desktop and Android both run on the JVM. So if you had like just JVM specific code, like code that wasn't messing with the Android SDK at all, could you, instead of duplicating the code, say having one implementation in desktop, one implementation in Android, could you just have one that's shared between those two?
I think you can do it if you have like a multi-module, so you have another multi-platform module that is targeting Android and desktop, and in that module's common main, you define it and then you put it in here, I guess. But I don't think it will let you define like a default for multiple platforms in one go. So the question was, sorry, I'm repeating questions after my answer. The question was, if for something that is common between desktop main and Android main, given it's running on JVM, if we can declare an actual, or if we can do an actual declaration of an expected function only once, and somehow tell the compiler to use this for desktop and Android. And I guess my answer was, I don't think there's a way until you create another Gradle module, which is targeting just Android and desktop, and you do it in its common source set, and then make this Gradle module depend on that module. All right, so now we're gonna, once the IDE has created all the stubs for us, we're gonna go into each platform and define our native coin module that we want to inject into the DI graph. So as I mentioned, for KDAR, the configuration goes into common, but we need to define the client engine for platform-specific things. So for example, I'll go into Android and define my coin module where it's going to inject a singleton of HTTP client engine type, and it's going to be an Android create. So coming back to the previous question about interface being declared in the common, so HTTP client engine is in the common module, and we're just providing the Android implementation of it in the native source set. Similarly, we do same thing for other platforms. For desktop, we're going to create like a Java client. For iOS, we're going to create a Darwin client. For Wasm, we're going to create the JS client. So one thing I want to highlight, even though, for example, this is the Android module for native. This client obviously is only accessible for the Android source set. So you cannot, if you try to import it, it's not going to import it because in the common module, it doesn't really know about it. It's just Android specific. All right, so next thing we're gonna do, we're gonna initialize our DI. So ideally, if you're have been working on Android, this is the first thing you do when your app is launched. So we're gonna do it similarly for all the platforms. So you see, I've created this function init coin, which takes like a lambda for coin app declaration. And let me tell you why I have this. And you'll see this pattern pretty much everywhere on the multi-platform apps if they're using coin. So maybe let me go to the Android main here. And I have this my application class where I'm calling this init coin. So if you want to inject something native to your DI graph, this init coin takes in a lambda. So if I go into the definition of this function, it's taking this lambda, which is called in here. But I can do like Android specific things in here. So for example, Android context is this. So in my graph, I'm injecting Android context, and this is the main application. So at runtime, whoever's gonna request Android context, they will get it. But obviously, Android context is not available in the common module. So that's why we have this like a common function, but you call it on each platform. Obviously, if you do not need to do anything platform specific, you don't need to. You can keep this function like internal and just call it in your common module. But we're exposing it, and we want each platform to call it if we want to inject something that is native to that platform.
What's the return side of this?
It's coin application. So I have seen different patterns, different places. This is basically like an instance of the graph. If you are doing something, I think it's no, it's more like on iOS side of things. If you wanna grab something from the graph at runtime, you hold a reference to whatever this is gonna return, which is the coin application, and you can just do. So let's see, I'm gonna go to.
Basically like interact with the data structure directly.
Yeah. So it doesn't feel right, but I've seen everyone pretty much doing that. So yeah. So for example, if I go in, yeah, sorry, no, I'm not used to that. So the question here is why we are returning the coin application in here, and coin application is coming from coin. Yeah, the question is why are we returning it here? And the reason is if for some reason on any platform you wanna grab something from the DI graph at runtime, you hold the reference to this coin application and you can just grab whatever you want at runtime.
That would be optional though, right? Return time, you can return.
Sure, yeah, it's optional.
It's not being used at the moment, right?
Yeah, so the question was if it's really needed or it's optional. The answer is yes, it's optional. If you're not using it, you don't need to. But I think once your app starts growing, there'll be a point you'll definitely use it at some level, especially on the iOS side of things.
So at that point, when it's returned to the previous thing,
Yeah.
how are you holding it?
So this app is not holding it.
Oh, right.
But if you want to use it in iOS, let me maybe show you here. So the question was how we hold a reference to it and use it at runtime if we want to. So I'm gonna open up like iOS app. This is Swift code, so this is like alien territory for me, but so over here, I think you'll just do, I guess they do coin or something. And it's like holding like a global reference somehow, which is not ideal. Nobody likes global references, but I've seen people using it. So
It's fine, it's like a sample app anyway.
yeah.
We'll find out later.
Yeah, but I'm not using it in the app. You can do it, but I'm not doing it. Cool. That was a good question. Yeah, so initcoin will basically start your DI graph, put all the modules in here. So if you remember, we had this platform module function, expected actual declarations. And this is where I'm injecting everything. So this is in the common module. If I go into it, this is the expected function that then at runtime, when you're initializing your DI graph, depending on the platform it's running, it's gonna use the actual declaration for that platform that you have provided before. So if you're running on Android, it's gonna, where is Android? This is Android. It's gonna basically use this declaration for that expected function. I'm sorry?
It's kind of nice with coin.
Yeah, coin is pretty cool. I like it. If you remember the days from Dagger, obviously Dagger is like all compile time. So it gives you, if you have errors in your DI graph, it will yell at you at compile time. With coin, everything is runtime. So if you mess up your DI graph, it will throw out an error at runtime. Your definition is missing and things like that. That's a caveat, but coin is easy to use, easy to extend.
Is a question on line 24, is that get an expected function?
No. So the question is on line 24, what this get is. So this get it basically coming from coin. So if I click into it and you cannot see it, oh, there it is. Yeah, it gives you an instance of the type.
Okay.
So from the graph. So if I go back, so this is KDOR configuration, HTTP client, which takes an engine, and I'm basically telling it it's declared in the graph somewhere, go get it. And obviously we're declaring it using this platform module here.
Would it answer all?
Yeah.
Aren't we returning HTTP client in the expect? Should we instead return the in or am I misremembering?
Yeah, so we're not returning HTTP client, we're returning HTTP client engine.
Okay.
Yeah. So HTTP client is, so the question was, if we are returning, let me go to one of these declare. If we are returning HTTP client or engine here, so we are injecting engine specific to the platform, which gets used by HTTP client. So yeah, this get is basically gonna look at the type, which is HTTP client engine, and it's gonna try to grab it from the graph. Obviously, if you don't declare it, so if, for example, if I remove this at runtime, when I try to use the HTTP client, it's gonna say, hey, I couldn't find its definition. So yeah, that's like the biggest difference between Dagger and Coin or any other runtime dependency injection. You get to know about your mistakes at runtime, not at compile time like in Dagger. Cool. So this function over here I want to highlight is something interesting I saw in one of the apps I was looking at on GitHub. They have declared like a separate function just to be called for iOS, which removes the lambda, and it doesn't, I guess it does have a return type, which will still be the coin application. But you don't really need this. You can still call this. However, you need to know a little bit of Swift. because then you need to know how lambdas work, how do you declare it like a default or a null, things like that. But if you want to avoid all of that, just declare it like this, and it will basically call this function up here with like an empty lambda. I also want to talk a little bit about, so if you had heard about TouchLab, they are maintaining this library called Ski. I haven't had a chance to use it, but it's doing something cool where it generates code on Swift side of things, which is more Kotlin friendly. So if I go in here, if I show you my iOS app, I'm calling like file name with the KD suffix and do init coin, right? But that's not the name of the function I declared in common module, but this is how Swift recognizes it. But I believe what they do with this ski plugin, it's gonna generate like an abstraction or something, and you can easily just do init coin and voila. But I haven't used it, so if anyone is curious, feel free to try it and let me know how it is. I wanna look at it. Cool. So once we have declared all of this, I think our DI is ready to go, and we have Ktor configured here with the engines we want to use. Ktor has a bunch of configuration things you can do, I think, like follow redirects configuration. If you want to do logging, we can install, I think it's like, maybe it's another dependency for special logging. But yeah, everything related to Ktor configuration would go in here. You can do like expect success so for example, if you're doing debugging stuff, you want to maybe turn it off. And I think you can also configure like timeout. So for, I think by default, whatever your client engine is on the platform, but I think it's kind of standard of 10 seconds on each platform specific HTTP client. But if you want to change the timeouts, you can do that in here. All right, any questions so far, anything online? Let's see. All right. Sweet, no questions. I feel like everyone is following along. Doesn't feel like a maze.
It kind of feels like watching a video game that I want to play, but I don't want to play.
Yeah. Yeah, it is kind of with the whole Kotlin multi-platform, and I have done it. I'm obviously doing for the mobile side of things, but for work, we have also done it for like doing SDKs on the back end. So all our front-end apps can, use the same thing. It's definitely, if you look at the curve, the setup time is definitely high. It takes you a while to set up everything up, but once you do, it's like applied it from there, and you can easily add more features. So I think that's something where KMP still needs to improve on, making all this build configuration that we're doing for each platform and things like that. But it's getting there. I remember a couple of years ago, it was still a mess. You'll run into all those, especially if you're building for iOS, you run into like crazy errors for on the compiler side of things, and you spend days on figuring it out. But it's getting better for sure. All right, let's see what we have next here. So yeah, like I mentioned, we're gonna call that init coin function for each platform. So on Android, we create an application class, call it over there inside on create. Then for desktop, it's a desktop app. There's nothing like an application class or a content view like iOS. So you basically just initialize it in a variable, and that's it. And you'll do the same for JS as well. But on iOS, like you have an iOS app, like we have main application for Android, you do it in there. Obviously, you can get fancy with it. You can do like a splash screen loading, do it over there, and once it's finished, you take your user to some other screen. If you want to make it more user-friendly, but usually it's pretty fast. Initializing the DI graph, even if you have a lot of components in there, it's pretty quick. All right, so with the repository, this is where we get into live coding. I do not have it in the slides, but if you're good on time, we can dive into it. I think we are. Yeah. All right. So the first thing, we want to set up a repository which will make calls to the weather API and provide latitude, longitude, get the forecast for the view model, but let's start with the repository. So I'm gonna, yeah. I'm sorry?
What is a repository?
Good. The question is, what is a repository? Repository is basically a set of, I really want to put it as, like, I don't think I've ever answered this question in a formal manner, but if I had to define it, repository is like, you have your GitHub repository, right? All your data is in there. So that's what it is in this context as well. Repository is the model in MVVM, if you're familiar with that. It's an interface between all your business logic and presentation logic and the data itself. And using repository, you'll store data, fetch data, do cloud sync, and things like that. All right. That's a good question, but I'll try to look up the formal definition of repository. All right, so basically create a new package in here. So we're gonna do everything in the common module. So that's something interesting. So we're not gonna do anything specific to the platform because we have the KTOR library that can manage everything for us. And we'll just do everything in our common module. Hopefully, we'll see. Down the road, if we need something that is required natively, we'll then do the actual expected declarations. So, declare new package, repository, and I'll create a new file. Let's call it weather repository. All right. So ideally, you'll do, if you're writing tests and stuff, you'll declare an interface and all of that. But for the sake of this workshop, I'm not going to do all that stuff. We'll just have one class with a repository. And let's do one suspend function called fetch forecast. It's going to take like a latitude. Is it a long? Like a double or something? Yeah. And all right, so we'll declare the model here. So for that, we need to go look up what the actual API returns. So I'm gonna go. What?
If you scroll down, API documentation is.
There, yeah. Is it? Yeah, this is it. So let's declare our like base URL first. So I'm gonna do nothing in here for now. Let's make it private. So base URL will be, I'm assuming this. And we're using the forecast API, so that's all we need. All right. So for anyone who's used Gator before, feel free to point out if I make a mistake somewhere. I haven't used it in some time now. So looks like it takes like a query parameter with forecast days, and latitude, longitude is also a query parameter. And then I want to see what it returns so I can declare my data model. This is such a weird documentation, I know. This was the only one I could find which is free. So, but I think maybe that's why it doesn't have a good documentation. Maybe I can just run a query.
It looks nice. Better than like I had to write it's just jarring. Sorry.
I remember in 2016, I was trying to use the Spotify SDK on Android. I was so obtuse, and
Let's see if that works. That didn't work.
just use the web.
Don't touch it.
Fair enough.
As someone who has re-implemented the Spotify API, yes.
I thought you were a less than FM boy.
I gave up on it.
All right, can anyone find the URL in there? Or unless I'm doing.
I see E1/WordPress.
Yeah, that's what I have here.
I think you have your query parameter maybe messed up.
It's so hard to see.
Yeah.
Is that like an extra after that question mark?
Let me see. Well, this is not gonna zoom in the URL, but
Maybe do www.
oh, maybe this is weird. Oh, no.
And it has to be like the
You have to add API or
So like API.
after,
Oh, there it is. Perfect. Thank you. So you need api.openmeta.com. So yeah, I'll just put it in here. We needed this API. It's a prefix. So this just returns like elevation and things like that, but we want the forecast. For that, I think we need to provide like, I think the hourly parameter. I swear I looked it up yesterday and I thought oh, there it is. So hourly will stay temperature. So we need to do, and hourly, let's just do this temperature. All right, we got something in here. I'm gonna do pretty print. For the folks who cannot read it, I'm gonna zoom in. This is what it returns. So I think it has like an hourly forecast. So yeah, these are 1 hour differences for time. And then we got like the temperature for each of those index. All right, so this is what our return model gonna look like. So I'm gonna go in here, define my data class, and let's call it like hourly forecast. And start with the latitude, which looks like float. Let's just go with that. I'm gonna ignore the things that we do not need and straight away jump to like hourly parameter here. It seems like an object, so we need an that. And all it has is it's just a list of string. And then bottom we have temperature 2M, which will be this is inside hourly, so it will be here. And it seems like a float. All right. So what I'm doing here is defining my model, but we also need to define for Kotlin serialization what the property names look like. So that's what serial name is for. So when it's doing the whole conversion, it knows in the JSON object which property to look at. So latitude is latitude, and longitude. Then we got hourly in here. I think time is time. So over here, it's the same thing. If you have used Kotlin serialization, even if I don't declare the serial name, it will be fine because the variable name is what the property name is. But obviously in here, they are different. So that's why I need to define it. But general practice, everyone follows this for consistency. You just define it. So it's not ambiguous. And then we got temp data, which is this guy. All right. So I guess we don't need this. So this, yeah.
Just a technical question. Do you know if GraphQL is supported?
Oh, I do not know that. Isn't
Apollo is the GraphQL client.
okay? Gotcha. Yeah, I haven't. So the question is if GraphQL has a multi-platform library or SDK. But yeah, I do not know. It does? Yeah, Apollo is multi-platform. Oh, there is a stable version. Kotlin, Apollo, Kotlin. Yeah, I mean, this is the old site. I guess Google is indexing, but they've put a highlight in here. They have a stable version.
That's good. It's good that they have
a stable
version of that.
Yeah.
That's cool. That's good.
Yeah.
Yeah, that's good to know for anyone using GraphQL. Here, you have a way to use it in Kotlin multi-platform as well. Cool. So this is my data model. I'm gonna return that in here, and then we need to make the actual call in here. So let's do that. We'll have to look it up.
My guess is X.
Let's see in here. Oh, sweet. We just need the client and that's it. So we're going to inject it as a parameter here. So, HTTP client. And I'm going to copy this. Or which will be our base URL. Then obviously we're gonna add the query parameter. I'm pretty sure Ktor has like a request builder or something you can do. Let's see. Okay, perfect. So client.request, we'll use the lambda in here. Query string now. I guess method. Let's get. So there's path, which we do not need.
Set request body, I see at the bottom.
Here?
No, you see the right hand side section.
Oh,
Set request body.
let's see. No, that's for like post or something.
Set request body.
Yeah. These are headers, cookies. I'm gonna just do search for it. There it is. Yeah. So URL parameters append. So what else we had? We got latitude, which will take the value of lat string. We're gonna add longitude. And this is a constant, which is oh, I guess we don't need that early. We can define a constant for that, why not? All right, so this will set up the request. I guess that's it. So response is an HTTP response, so we'll just do like print here. So we'll see what we get, and ideally we should be able to do body of type. I don't know if this will work. Yeah, but we need to somehow configure Ktor to use Kotlin X serialization. I don't know how it.
Did you also annotate your data classes with pattern types?
That's a good point. One thing that, I have missed it a lot of times, but anything you need to be serialized, it needs to be tagged with serializable. Sweet. Yeah, that's a good point. I don't think it would work, but let's run it. Let's see. Nothing ever runs on the first go. So we have this repository. Obviously, we want to inject it to our DI graph so it can be used wherever we want to use it. So I'm going to go. The good thing is here, unlike we declared the HTTP client engine for each platform, this is all common. So we just declared it in our common module here. So I'll say repository, and it takes a client, which we are already injecting. So we just need to do a get, and Coin will know it needs to use this. Cool. So without doing any view model or any UI, let's just see if it works, right? Easiest way to do it on maybe on a desktop app, or maybe not really. We can just do it in common. So one thing I didn't go over is the whole UI part of side of things. If you're using Compose Multiplatform, then you can declare all your UI in the common module, and it's basically like Jetpack Compose. So if you have done Android development, you might have heard about Jetpack Compose. It's using the same, I don't want to say same APIs, but the APIs look the same. So if you're familiar with Jetpack Compose, you can write the common code using Compose Multiplatform as well. So this is where the whole UI is declared. So this is where it starts. And this is all coming from the starter project we downloaded from the Multiplatform Wizard. So you can declare things same as you would declare in Jetpack Compose, like buttons and things like that. What I'm going to do here is on the button click, and this is just for this project for workshop. Don't ever make a network call on your main thread. This is just to see if our API or the way the repository is going to work. So first thing, I'm just going to do and I think it's called coin inject. Yeah. And I can do repository, fetch. Let's just do something random. Anyone want to pick latitude and longitude?
321.
And oh, did you mean like 3 latitude? Okay. All right. So this is not going to work. Anyone know why? All right. Good answer. So this is a suspending function, and it's not being called inside a coroutine scope or anything, so we cannot use it. And that was the whole reason I was doing all this, just to show you guys. I'm kidding. We can do run blocking or something.
So, right below repository, do val coroutine scope.
Yeah, you want to create like a scope.
Remember coroutine scope.
Yeah. That's it.
And then you're on click, you can launch.
All right, yeah. So complaining about, oh, that's a floating. All right, let's see. Desktop, run it.
It's actually not as slow as I thought it was going to be, all the runs.
Yeah, I mean, I think it's because I have some build cache local, but yeah. All right, let's click on it. And we got to look here. We got an exception. Ooh, what is that?
I think this is the serial section, so.
To like register the.
Yeah. Yeah, so we got into an error here, and everyone feels like it's something to do with serialization. So let's verify that, right? How are we going to do that? I'm just going to, instead of reading it as a hourly forecast, I'm just going to read it as a string. So I guess let it fail here, but I'm going to do, it did put a response, print out a response code of 200. So that is good. So at least our KDAW request made it through. Yeah. Let's run it again. We should still see the error, but right before that, we should see the JSON content. And we do see it. Awesome. So yes, it is something to do with serialization. So let's Google up how to fix that. Kter client.
Yeah, there's all these plugins on KTOR.
Yeah, I think we need to add the JSON Kotlin serialization dependency. Oh, you mean the content negotiation? I think we just need this, yeah. So I'm gonna go back to my libs.
I think you need content negotiation one as well.
Oh, we do?
Yeah.
Okay. So it seems like we need two dependencies. Kter serialization JSON and I think I already have Kter defined, so we need to define again. And we need Kter client content negotiation. So yeah, I don't know what content negotiation is that.
So what I was reading, content negotiation looks at the headers of both the request and response for the requests. And it does that to make sure, like, oh, hey, you say in your header that you sent me back JSON, let me try and decode that as JSON. And then once the negotiation between the client and the server is happy, then you actually perform the JSON deserialization with a separate piece. That's why there's two pieces. It's like a validation. Kind of.
Gotcha. So for the folks online, the question was, why do we need this content negotiation dependency? And the answer was, when you're making a request, it looks at the headers for content type and kind of do some validation to make sure what you're saying is what you are getting. All right, so declared in the toml file, time to declare it here. Need to do a sync. I guess stop the running app. Okay, there you go. Kotlin serialization JSON. It's still syncing, so it doesn't know about it yet. But this was content.negotiation. I'm just gonna do it. Let me spell it.
Yeah, you can put serialization on that one.
That's good. All right, perfect. How do we set it up? Let's see.
It's in the HTTP clients.
Okay, install content negotiation. Yeah. So we go back to our coin. This is where we declare HTTP clients. So we'll do JSON. First, I just want to verify this JSON is coming from. Yep. Sweet. I think that's it, right? Let's run it. Let's click, go back in here. Ooh, we got, all right, so we get this error where it's trying to convert the whole model, but there are some properties, which are the keys in here. It's not able to figure out what they are. So I think what we need to do is go into with the repository, or maybe not. We need to do it in here. Yeah. So JSON equals to JSON, and we do, is it called ignore unknown keys equals true? Right. So for everyone, this is what we're trying to do here is the model that we get back from our API has a bunch of different keys in there, but we do not need all of those keys. We only need the keys that we have defined in our data class here, but we explicitly need to tell our serializer that, hey, ignore anything that is unknown. So that's what we have here. We say for the JSON type of serialization, ignore unknown keys. And no errors. So that worked. So what I'm gonna do is here, just print it out so we can see the actual model. Run it again. Yep, and this is our final data model. So we got everything. I know we're on time, so I'll pause here. But if folks are interested, we can obviously carry it on in future, build more on it. I would definitely like to tap more on the UI side of things and explore Compose multi-platform. So yeah, if everyone is interested, we can definitely do more of this and expand on it. And at the end of the day, maybe we'll end up with a very fine looking app that you can put on the store or use it yourself to check out the weather. Yeah, any questions online or over here? Oops, I'll start.
Does anyone have any, what questions do people have? Any last minute ones? Okay. All right. Well, I don't know if there are no questions. If you do have questions later on, feel free to ask in the Kotlin Lang Chicago chat. I know Kartik is on there.
Yeah.
Yes. Thank you so much, everyone. I hope everyone enjoyed the KMP meetup. I definitely did. I learned quite a bit. There was a lot of nuances, like even in like the most simple of labs, and that requires a lot of detail to attention to detail. So
Yeah.
Thank you so much, Kartik. It was
Thank you.
really, really good. Thank you. All
Thank you,
right.
guys.
Yes. Okay. And thank you to everyone for watching. You know what? I just realized that I have to turn it off on my computer. So thank you to everyone. Have a good night. We'll see you at the next meetup. So we'll just go on live, and if you guys like, you can go to Turtles. It's not raining today. Yeah.
No, I gotta get back to this studio, unfortunately.
Studio.